Hello everybody, I'm William Osman from Family.com. I'm in Jingmai right now, and today I'm going to talk about soil. Soil is very important to the plant because it provides a physical support, air, water and nutrients. So in order to better understand the relationship between soil and tea growth, let's first look at what soil is made of. So now we're going to go down the slope and take a good look at the origin of soil. I'm standing here on the northern slope of Jingmai Mountain. Next to me you can see the bedrock and also a bee nest. I think it's a bad idea to stand next to a bee nest, but there are no bees, so let's see what happens. Soil is simply ground rock. The rock is slowly weathered by physical and chemical processes. Most of the time it requires water. That's why in the regions with high rainfall, such as subtropical areas, soil tends to be created much faster than in dry areas like deserts. It generally takes thousands of years to form a decent soil layer. In any way, soil formation is not a process you can observe within a lifetime. So you can see this bedrock has several layers. In some parts of the mountain it's pretty hard, and in some parts it's very friable, it's very easy to tone apart. The color of the stone is generally dark green. In some parts of the mountain you can also encounter some silvery white stones with hints of green. You can also see incrustations which seem to me like quartz. So traces of oxidation, such as this rust here, are visible in many parts of the mountain. This indicates that water flows through this rock. After a couple of on-field observations, I looked for a geological map of China on the internet, and here's what I found. They put the soil of Jingmai Mountain into the Kunyang group. So I looked for more info about that Kunyang group, which is pretty hard to find because there's basically no translation in English. And I found that this group of bedrocks included sandstone, phyllites and slate. Then I searched for a long time on the internet about all these kinds of rocks because I'm really not a geologist. But according to the descriptions on the internet and my observations on field, I would say that this rock looks like phyllite. If there is a rock hound hiding among you watching, I would love you to email me and give me more information about phyllite. Back to soil formation. As I just said before, soil is formed from rock weathering. So it means that the rock is slowly ground first into big particles, which we call sand. Then those big particles, this sand, is ground into smaller particle, which we call silt. And finally, this silt is ground into even smaller particle, which we call clay. So I'm just gonna collect a soil sample of this plot in the ancient tea gardens at low elevation on the northern slope of Jingmai Mountain, and we'll be done here. I'm now on top of Jingmai Plateau called Tapingzhang, on which about half of the ancient tea gardens are located. I'm standing here at an altitude of 1,550 meters, and we're gonna check the soil here, see if it's different. So we're gonna collect a soil sample here and go back home and compare it to the sample we just collected down the slope. Okay, here we are. I'm gonna add those two samples on the plate. So this is the first sample that we collected down the slope at an altitude of 1,250 meters. I'm just gonna put a little bit of it, and next to it our second sample that we collected on the top of Jingmai Plateau. First, what you can see is the first sample that we got down the slope is still wet, while the second one is not very wet. It's almost totally dry. It hasn't rained for about 5 days, so that gives us some clues about the water holding capacity and drainage capacity of each soil. They were both collected at about 10 centimeters below the surface. We can start by trying to feel the texture of soil. Just take the soil in your hand and try to make a ball. I'm gonna add a little bit of water. So I add water in order to better make the difference. For each of them we're gonna try to make a ball. Okay, so as you can see now I'm getting my hands very dirty. That's what it is when it comes to soil science, huh? So this one is the soil found on the top of Jingmai Mountain, on the plateau. That one is found on the slopes. So we can assess their texture. Soil texture means the relative composition of soil in sand, silt and clay, and we're going to try to evaluate this by feeling it. There are more accurate measurements that can be done in a lab, but we don't have the tools here. So we're going to try to make a nice little sausage and try to fold it. See how far we can fold it. Okay, let's work it a little bit more. Can we fold this one? Yes. I would say it has a lot of clay and silt. Not that much sand. When you have a lot of sand, if you press it, you can feel it's gritty. But here, even though I press hard, I can barely feel, I can't feel many sand particles here. Just a little bit. And I would say it's not pure clay because it's still not entirely flexible. So yes, I would go for a mix of silt and clay and not much sand. Now let's go to our second sample, the one from the top. This one, you see, I can't work it like the first one. If I press it like this, it holds, which means there is some clay in it, but as soon as I press a little bit on it, it just breaks. And it's pretty hard for me to work it like this, because you see, if I work like this, it just becomes many smaller pieces of soil. Now when I press it between my fingers, I could say I can feel a lot of sand here. So I would say it's a mix of sand and clay. I'd say there's much more sand here than in the first sample, and I would even say sand makes the majority of this soil. If you look at the dry soil, it's quite clear there's a lot of sand. You can just hear that noise when you crush it between your fingers. So I would say those two soils are really different, huh? Those two soils are really different. On the top, I'd say we have a sandy soil. On the bottom, we have a soil made of silt and clay. The size of the soil particles is very important regarding air, water and nutrient holding capacity. Sandy soils allow air to flow through very easily, but they also allow water to drain very easily. Clay soils, on the other hand, retain water much better, but the air doesn't flow through the soil as well. Lack of air can be a big problem for the plants because the roots need oxygen to function, and that oxygen is taken from the soil. They have no way of taking it from the atmosphere. Also, only clay can hold a significant amount of nutrients, which means that whatever the amount of sand or silt that you have in your soil, what determines how much nutrients your soil can hold is the amount of clay. But too much clay in a soil can be a problem because the soil will be easily waterlogged and will have a hard time draining out water. So generally we consider that the best soils have 1/3 of clay, 1/3 of sand and 1/3 of silt. We say generally tea doesn't like to have its feet wet, which means if you grow tea in a soil with high clay content, maybe you should take specific measures to prevent soil from being waterlogged. For example, you can dig small trenches around your field. Building terraces is another way to facilitate water flow through. Oh, and I haven't mentioned soil pH yet. According to a scientific paper, the pH on the top of Jingmai Mountain in the Jingmai Plateau called Dapingzhang is comprised between 3.7 and 3.9, which is extremely acidic. According to the locals, the soil is less acidic down the slope. Soil pH has important consequences on nutrient availability because an acidic pH will favor some kinds of nutrients, while an alkaline pH will favor some other kinds of nutrients. Too low a pH can also make plants vulnerable to toxic elements such as aluminium, which is widely present in the soil but is not really toxic when the pH is high enough. Tea can grow in highly acidic soil, and this is very specific to the tea plant. And such a low pH on the top of Jingmai Mountain can also explain why people planted tea there and not another crop. Now the consequence of soil pH on tea quality hasn't been studied. It's probable that if we increase the pH a little bit, the yield will be better. So to summarize, We found two different kinds of soils on Jingmai Mountain. One sandy, acidic soil on the top of Jingmai Mountain, and one more alkaline soil made of silt and clay. This provides different growing conditions for the tea trees and probably has an influence on the taste of tea. We also identified the bedrock at the bottom of Jingmai Mountain, which is supposedly phyllite. In any way, we hope you'll enjoy our productions in 2017 and will be able to find differences between tea grown on sandy soils and tea grown on clay soils. Thank you for watching.